Learn how to fix AI agent reasoning in dynamic environments like web browsing or robotics without adding computational complexity. Your agents are failing because their reasoning disconnects from reality. They think they are making progress, but they are actually creating dangerous gaps between what they believe and what they need to accomplish. Current error prevention methods completely miss this core reasoning issue. But there is a breakthrough that grounds every decision your agent makes before it acts. React framework agents often generate ungrounded or incoherent reasoning, which creates a dangerous gap between what they think they're doing and what they actually need to accomplish. This misalignment triggers compounding errors and hallucinated actions that snowball into complete failures, especially in complex environments where the agent can't see everything. Current fixes like reflection or WKM just slap extra modules on top of React, but they are missing the core reasoning issue entirely. Here is a breakthrough. Instead of just predicting the next move, agents need to constantly check their internal belief state against what they are actually trying to achieve. Because ungrounded thoughts are the cancer that kills reliable actions. You need explicit state goal reflection to ground every decision your agent makes. ReflAct creates a new reflection action loop, where the agent stops to think about where it stands and what it is trying to do before making any move. Let's have a simple example. The agent needs to cool some lettuce and put it in countertop. So the agent goes and takes this lettuce from countertop 2, and then it tries to cool it. But then nothing happens, and it basically fails. But here is the key. Instead of just getting stuck, the agent reflects and realizes, oh wait, I need to actually be at the fridge to use it. So it goes to the fridge first, then successfully cools the lettuce. And this is how ReflAct helps agents to self-correct. Because when something goes wrong, they can figure out why and fix their approach, rather than just repeating the same mistake again and again. And because of the way how LLMs work, basically generating next tokens based on the probability, the closest the initial state is to the action, the more highly likely it would generate the right action. Because the more things you put in between, the more it starts forgetting and being confused of what to do next. ReflAct was tested with LLaMA 3.1 and GPT-4o across LLF world, household tasks, science world, scientific procedures, and also Jericho, interactive fiction games benchmarks, and consistently outperformed React, No Thinking, and Plan and Act baselines. And at this picture we can see a clear performance jump over each of the different approaches across these two models. These are the failure ratios you can see at the image. This way, by simply anchoring actions to the current state and the goal, it slashes hallucinated actions. Here is another example. The agent needs to boil leaves, and in order to do that, first it needs to focus on the substance and then take actions that will cause it to change its state of matter. And below we can see the outcome of React and ReflAct approaches, and in React we can see that it mistakenly believes it is already holding the lead, and when it tries proceeding with the task, it fails, obviously. In the other example, it actually first reflects on its current state, correctly recognizes the situation, that it actually needs to pick up the cup first, ultimately leading to task success. And compared to heavy computational methods like RAFA, ReflAct delivers better grounding and efficiency with just one single LLM query per step, which is incredible. By making agents check their internal state against their actual goals before every action, ReflAct fixes AI agent reasoning errors in dynamic environments. Agents now verify where they actually are and what they are trying to achieve, instead of just predicting what to do next. The full paper, linked below, reveals the exact instruction that makes agents self-correct, explains why they believe they're holding objects when their hands are empty, and demonstrates the breakthrough insight about belief state tracking. You will see how this prevents the reasoning loops that break other approaches and why it works across robotics, web browsing, and complex reasoning tasks without additional training.